Okay, now ray diagrams for spherical mirrors. So this bit is important because in PSPM, they would ask you to draw the ray diagrams lah. Okay, so ray diagrams is defined as the simple graphical method in which help to indicate the positions of the object and image in a system of mirrors or lenses lah. Okay, so this are the graphical method in order for us to locate an image formed by concave and convex mirror lah. Okay, so if you have problem remembering what is concave mirror, if you look at the word cave, the mirror is actually kind of look like a cave. I mean, it caves inside lah. Okay, macam tu je lah. Alright. Now, so for concave mirror, So for the ray 1, the red color line, it would go from the object, from the top of the object, it goes parallel to the principal axis, so it is parallel to this principal axis here, and after reflection it will pass through the focal point. Okay, same thing goes for the convex mirror, but since for convex mirror they are just it would just apa kamu akan draw, what is this, dash line lah instead of solid line to show that it is formed behind the mirror. Okay, so all this dash line is telling us that it is formed behind the mirror. Okay, so it is being reflected like this through the focal point. Okay, and then the green color line, ray 2, it passes or directed towards the focal point. Okay, so you draw it from the top of the object through the focal point and reflected parallel to the principal axis here. Okay, all right, same thing for the convex mirror, passes through the focal point and then draw from the mirror parallel to the parallel axis pula, principal axis, sorry. Okay, now the blue line, the ray number 3, it passes or directed towards the center of curvature and then reflected back macam tu saja along the same path. So it's basically 90 degree to the mirror punya surface lah. Okay, so if it was me, because we only need to draw a minimum of 2 rays, I would just remember ray 1 and ray 3 lah, the red and blue color. But actually it's not really hard for you to remember the step in drawing each of these rays lah. Okay, you just need practice. Okay, now images formed by a convex mirror. Okay, so for a convex mirror, there is only for convex mirror there are just so the characteristics for a convex mirror punya image is only this here lah. Okay, the one yang banyak is the concave mirror lah. So for convex mirror, the characteristics are virtual, so it is seen to form by a light coming from the image, but the light does not actually pass through the image. Okay, so it wouldn't appear on paper, screen or film placed at the location of the image, and then it is upright and diminished and it is formed behind the mirror. Okay, see, you can see the image is formed behind the mirror. Okay, actually I forgot the line where the point where each of this line intersect is where the images form lah. Okay, so kamu tengok di sini, each line is intersect here, so the image would form here lah. Okay, all right. And then the object position is in front of the convex mirror. So usually convex mirror is used as a driving mirror lah because it has a wide field of view and provides an upright image. Okay, next, so this is for the concave mirror. So this is actually a lot. You just need to know, I would say, memorize the image characteristic, but if you are able to draw the ray diagram, you don't actually have any problem in knowing the characteristics lah, because if you would see, this is inverted and then it is formed in front of the mirror, so it is real, and then if you look at the size, this is smaller than the object, so it is diminished and then formed in front of the mirror. That is formed between point C and F is one of the characteristics lah. Okay. Alright, so the applications are shaving and makeup mirrors, since it provides an upright and visual images. Okay, now linear or lateral magnification M, so it is the ratio between the image height and the object height, where V here is the image distance from the pole. Okay, U pula, it is the object distance from the pole. Alright, so the spherical mirror equation pula, this is, you need to apply this lah in a situation. So basically it the object distance U here would be positive if the object is in front of the mirror, negative if it's at the back of the mirror. V here is the image distance, it will be real if it is formed on the same side of the object, virtual if it negative if it is formed behind the mirror. And then focal length will be positive for concave mirror, vice versa. And then magnification is positive for upright image, and then negative for inverted image lah. Okay, so note that real image is formed by the actual light rays that passes through the image, hence the real image can actually be projected on the screen lah. Alright, so that is on drawing the ray diagrams for spherical mirrors. We will go into example in the next video.